Hi, hi. Today we shall be developing panel data using following methods. Number one, pooled model. Number two, fixed effect or LSDV model. And number three model is random effect model. And here we have taken 6 computer farms such as 111, 222, 333, 444, 555, and 666. And we have 3 variables such as cells of computer in volume, price of the computer, and the repairs of computers. And here we want to check the relationship between cells and other two variables such as price and repairs. And so here our data is from 2000 to 2010. So our observation would be 66. So here actually our data is here. I can show you my data. Data are here. You can see. So actually, so here you can see year 2000 until 2010 multiplied by 6 because we have 6 farm. So total is 66 our sample size from 2000 to 2010, and these are our data: price, repairs, and sales, right? So here I am opening the data as a group. So this is my data, right? This my data is here. You can see the price of the computer, repairs of the computer, and the cells in volume, right? So this my data, you can see, right? Okay, this my data are here, and here you can see cross sheet, right? Cross sheet are here, right? Okay, so this is my data, and here you can see the range is this one, sample is this one, you can see, right? All are here. Okay, now we see something. Okay, so here actually what is our target, right? So we have 3 models. So the first one is the pooled model, that is the first model. And here we pull all 66 observation together and run the model, neglecting the cross section and time series nature of data. But here the major problem with this model is that it does not distinguish between the various computer companies that we have. In other words, by combining 6 companies, by pooling, we deny the individuality or heterogeneity that may exist among 6 computer companies. So that is the only problems. And here we assume that all companies are the same. But normally it does not happen because 6 companies should not be same all the time. but here we assume that all the companies are same when we run the pool regression model. Okay, our second model is the fixed effect or LSDV model. The fixed effect or LSDV model allows for heterogeneity or individuality among 6 computer companies by allowing to have its own intercept value. So it should be 6 company, not 5. We have 6 company and they are 111, 222, 333, 444, 555 and 666, right? So we have these 6 business, 6 firm. Okay, the term fixed effect is due to the fact that although the intercept may differ across computer companies, but intercept does not vary over time. It is time invariant. So meaning that here 6 computer companies should be individual, right? So that we assume here, and they have 6 and they have their own intercept value, and that is fixed effect or LSDV model. Then our third model is a random effect model, and here our 6 companies have a common mean value of for the intercept. Okay, that is random effect model. Okay, now after estimating the above 3 models, we shall uh, we shall have to decide which model is good to accept. Okay, so to check it I must use the Hausman test to check which model I should choose. And now we shall apply Hausman test to check which model, the fixed effect or random effect, is suitable to accept. So here actually we have the Hausman test, and here what is the null hypothesis? The null hypothesis is random effect model is appropriate. And what is alternative hypothesis? Fixed effect model is appropriate. And if I get the statistical significant p-value, I shall use the fixed effect model, otherwise random effect model. Meaning that if the p-value is less than 5%, we shall reject null hypothesis and accept alternative hypothesis, meaning that fixed effect model will be appropriate. But if the p-value is more than 5%, we cannot reject null hypothesis, rather we accept null hypothesis. meaning that random effect model will be appropriate. Okay, now I shall start the model. So I shall this is my model, right? This is my model. So, and we have the data, right? Okay, so first I estimate the pooled model, right? That I do first. So meaning that the first I estimate the, I'm sorry, just I take it up, just one minute. Okay, so first I run the pooled regression model. Okay, okay, so that I do. How to run? I go to quick, then estimate model, right? Okay, so here our cells is the dependent variable, C is the constant, then I put price, then repairs, right? I put all these things, right? So here is the cells is the dependent variable, and price and repairs are the independent variables. So here I am pulling all the data, all the 6 companies together. Okay, I then click OK. So this is the outcomes of the model. You can see this is the outcomes, right? Of our model's outcome is here. Okay, here you can see. So the cells is the dependent variable, and price and repairs are the independent variable. Here price, the variable, it is significant because probability value is less than 5%, but the second variable repairs is not significant because 23.53% is the p value, that is more than 5%. So here only the price is a significant variable to explain cells, and that is our dependent variable. But here we assume that all the 6 companies are same, but that normally does not happen. So we cannot accept the outcome of this pooled regression model because we assume that all companies are not same. Okay, then we can run our second model, that is fixed effect or LSDV model, right? Okay, we can run it. I go to quick estimate model. Okay, sorry, I have done a mistake here. Okay, estimate model. Okay, this is fine. I put the cells is the dependent variable, C the price and repairs, right? I pull all these things. Then panel option, I select the panel option, I click on it. Okay, here is same, only here I bring a change. Here, just here I select fixed effect model, right? I select this one, then only I change here, right? Fixed, then I press OK. So this one is the fixed effect model, right? You can see from here. Okay, here is the cells is the dependent variable, and price and repairs are the independent variable. And here the price, actually the price is significant variable because p value is very small, but but the second variable, repairs, is not a significant variable, but price is a significant variable to explain sales. Okay. Okay, after it, we can run the number 2 random effect model. Okay, random effect model. We run it now. Okay, go to quick as before, estimate equation. I write sales, then constant, then price, then repairs, right? Okay, then I go to panel option. Okay, only here I select random. I select random. Only I change here, right? Other remain as before, right? So I press OK. Then yes, okay. So this one is my random effect model. And here you can see the price. The price is a significant variable because probability value is very small, and repairs, the probability value is 85.26%. So repairs is not a significant variable. Okay, now the question is that out of these two model, that means out of fixed effect model and random effect model, which one is appropriate? Which one is appropriate, right? Sorry, which one is appropriate model? Appropriate, right? Which one is appropriate model to accept? So that is the question, right? Okay, which one is the appropriate model to accept? That is the question. Okay, to answer it, we should run Hausman test, right? Hausman test. Okay. So so I go to quick. What I do? So actually what I do? So okay, just 1 minute. Okay, what I do? So here, just I go to view, right? Because this one actually so the this model actually random effect model that I have just measured. So this one is the random effect model that I have just measured. So from here I go to view, then I go to fixed effect testing, then I select this on Hausman test, right? I select this one, Hausman test. I click OK. Okay. So this one is the Hausman test. Okay. And this one is the cross section random chi-square value and the probability. Okay. Here, what is our null hypothesis? Null hypothesis is null hypothesis is what? Null hypothesis is, I'm just 1 minute, the random effect model is appropriate. Random effect model is appropriate, right? That is the null hypothesis. And alternative hypothesis is fixed effect model is appropriate, right? So one is null and one is alternative, right? Okay, here what is happening? The probability value is 87.20%, which is more than 5%, meaning that we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that random effect model is appropriate, right? Meaning that random effect model is appropriate. Okay, so we estimate the random effect model now again, right? Again, we run the random effect model. So here I go to quick as before, estimate equation, cells C, then price and repairs, right? Okay, then panel option, then here I select the random effect model as before, right? Then press OK. So this is my appropriate model, random effect model, right? You can see random effect model. Okay, here what is happening? Price, this one actually significant because p value is less than 5%, but the repairs is not as significant because p value is 85.26%. That means price is a significant variable to explain our dependent variable, which is cells. But here is one problem. The coefficient of price is positive, right? Here it is positive, meaning that when the price goes up, sales goes up, and when the price goes down, sales goes down. But it is against the economic theory. So normally the price sign should be negative, but here it has been positive. Normally what happens? When the price goes up, sales goes down, or if the price goes down, sales goes up. That is economic theory. But this one is plus, right? Meaning that it is against the economic theory. So I have doubt. I have some doubt about our random effect model as it is against the economic theory, right? It is against the economic theory. Okay. Thank you very much for being with me for a while.